Hello, and welcome to Elementary Algebra with me, Professor Eric Newman. Now, I'd like to start this semester off with asking you a few kind of big picture questions. Right? You're taking an elementary algebra class, so it might be relevant to know the answer to this question. What is algebra? Right? We're taking an algebra class, we should know what that's all about. For that matter, what is math? Some of you might have given as your definition for algebra, it's a math class. Okay, so what is this thing called math? Right, well, not everyone gives the same definition, but I'll give you mine. Math is a logical system, symbolic and theoretical constructs created to accurately represent reality. Fix that typo there. Math is a logical system of symbolic and theoretical constructs created to accurately represent reality. Right, all the symbols that we're used to, people came up with those symbols. Those were invented. But they were invented in order to represent real things. 2 apples, 2 penguins, that's a quantity called 2. And we can represent that using our system. Right, now the system is much more complex and broader than any of you might imagine. People are doing brand new research within mathematics every day. Thousands of people are creating new ideas or discovering ramifications of other people's ideas, and it's a very vibrant field. One of those fields is called algebra, and if you are a professional PhD mathematician, you would say algebra is the study of the structure of mathematics. You can talk about different algebras, and it gets very theoretical and complicated. For you guys, we're not going to use that definition. We can get a little more applied and say algebra is the study of relations and operations. And we'll define what relations and operations are in a later video, but hopefully you've seen those words before. And notice I'm not talking about numbers or variables yet. Right? Numbers and variables are definitely important, but they're not as important as relations or operations. A third definition of algebra, and I hope you're writing all of this down, right? A third definition of algebra is the application of arithmetic principles to unfamiliar situations. And that's probably more akin to what most of you think of when you think of algebra. Doing arithmetic with variables, right? And variables are how we deal with unfamiliar situations. One way that we deal with unfamiliar situations. That gets to a broader point I want us to see before we even start working on any problems. And that is what mathematicians do. What do mathematicians do? I'm not talking about the research people, the people who are doing math. What are most people doing when they do math? Well, mathematicians create models of unfamiliar real-world situations. That's the heart of it. They're creating models. And they use these models to uncover truth, make predictions, and make decisions that optimize the use of scarce resources. Let me fix my typo back here. Mathematicians create models of unfamiliar real-world situations. They use these models to uncover truth, make predictions, and make decisions that optimize the use of scarce resources. All of the 2x plus 3 equals y stuff is worthless unless we can use those ideas in the real world. And so we'll focus a lot on applied problems this semester, on real world situations, and using our algebraic framework, our models, to do these three things: to uncover truth, to answer questions that we don't already know the answer to make predictions, um, to deal with situations we don't know the answer to and can't find out the answer to until we actually do something, but we're predicting what's probably going to happen. And we do that in order to make decisions. Making important, correct decisions is really uh, why we use math, right? We want to optimize the use of scarce resources. We need to know where to allocate the N95 masks, where they're going to be the most needed and be put to the best use. Right? We're not going to get into all of the statistical models, and epidemiology goes really deep in the mathematical modeling, far beyond what we can do in this class. But it's really just further along the path that we're starting out on now. And so I hope you have that written down as with the other definitions. So as we look at these models, right, they kind of come in two flavors. So why don't you think for a minute about what an algebraic model might look like? Go ahead, write that down. All right. You may have written something that looks like this. Something that looks like this. Or maybe something that looks like this. These are two very different models. This is what we call an expression. And this one is what we call an equation. What's the difference? Right, that big thing there. So let's give these formal definitions. An expression is a meaningful collection of numbers, variables, operations, and/or grouping symbols. Whereas an equation is a mathematical statement that two expressions have the same value. A statement has a subject and a verb. Right? We're looking at two different things being equal. Each of them is an expression. So when I look at 3x plus 4 and I look at 7, each of those things are expressions. An expression is a meaningful collection of numbers. Here's a number. Here are some numbers. Variables. Here's a variable. Operations. Here's one operation. Right, what operation is this? Good. Addition. Plus. Here's a second operation. I could have written 3 times x plus 4. So there's some operations and/or grouping symbols. I could have had the expression 3 times x plus 4 contained within parentheses. And now that's a different expression, right? Sometimes grouping symbols dramatically alter the meaning of the expression. If I'd written 3x plus 4 with parentheses around this, that's actually not going to have any impact. I would have done the multiplication first anyways. Right, so we're going to get into the different operations and what all these symbols mean. But from the get-go, it's important that we recognize what an expression is versus what an equation is. And we can do different things with each of those mathematical objects. I'll say one last thing about expressions. For an expression to be meaningful, we just mean it's not something like right? That's gobbledygook. You can't square a multiplication. We have an open parentheses that's not closed, a closed bracket that never got open because parentheses and brackets aren't the same. They mean the same thing, but they don't go together. In an expression, you can't do that. Right? Is this an x sub 2? Is that a variable? Or am I trying to use 2 as some input to an operation? We need to be able to make sense of what's going on in our expression. Right? But we'll pretty much always um, give you expressions that are meaningful. It's just when you're writing things, it's important that you don't accidentally do something like that, where this does not have meaning because I don't know where this parenthesis is meant to close. That changes the definition here. Okay. Well, thanks for listening to this intro video. We'll get into actually doing some problems and a few more definitions in our next video.